Today, we'll be looking at 10 Python functions that will make your life easier. These can save you a ton of time and a lot of headache, and they get more and more interesting as we go through them. Now let's start with number one, which is the pprint function. Now in order to see the value of this, let's look at what happens when we try to load in a large JSON file like this. A lot of the times we'll have some JSON from a request that will have a bunch of data that we want to view in the console, but when we print that using a normal print statement, we'll get something very messy like this. I don't know about you, but this is very difficult to read. I'd have to go through and try to manually parse for different fields, and there must be a better way. In fact, there is with the pprint function. Now, pprint stands for pretty printer or pretty print, and if I simply use pprint.pprint, I can specify my data and optionally the maximum width, although I don't need this if I don't want. And now when I run my code, I'll actually get a nicely formatted object that allows me to more easily read through, in this case, JSON. But you can print anything that you want with the pprint function. For example, nested lists work really well as well, and you can really easily see what it looks like with nice formatting and indentation in the terminal. Now the next function on my list is the default dictionary function. This comes from the collections library, which is built into Python, meaning you don't need to install it, and this allows you to create a dictionary object that has a default value. What that means is that when you try to access a key that does not exist, rather than getting a key error, you're going to get whatever the default value is, which is dictated by the return of whatever the function is that you pass to the constructor. So this is how we create a new dictionary, default dictionary. We then pass inside of here a function. In this case, I'm using the int function, and the int function simply returns 0 whenever it's called. I could instead use the string function, so str. I could use something like the list function if I wanted an empty list. I could even use another dictionary if I wanted to do that. I can pass my own function as well, so just to make this clear, what I can do is define a function, so I can say define, and then we'll just go with default func like that. And what I could do is just return a value, say like 20, if that's what I wanted the value to be. And now rather than passing the int, I would just pass my default function. Notice I'm not calling it. And now anytime I try to access a key that does not exist, we're going to call this function, get this value, and use that as the default value. In order to illustrate that to you, I'm just going to get rid of the below example here, and I'm going to try to print out the word count at the key 0. Now currently the key 0 does not exist inside of my word count dictionary. This is just an empty dictionary, and you'll see that when I run this, I get the value 20. Let's clear this and go back. Now notice what happens if I were to change this to a normal dictionary, so just initializing it like that. When I run the code now, we get a key error because 0 doesn't exist. Let's go back to the other example I had, which is a good reason to use this default dictionary. So let's go back here. And you can see that in this example, what we're doing is keeping track of the frequency of different words that we have in this words list. And rather than having to check if a word already exists as a key in the dictionary, we can simply increment the count by 1 every time we process a word. The reason for that is that if the word does not exist, the value by default will simply be 0, so we don't need to handle that case. So just to quickly run this here, you can see that now we have all of the counts of the various strings that we had inside of our words list. The next function on my list is actually a combination of two, and it involves using pickle. Now this is pickle.dump and pickle.load. Now a lot of times when you're working in Python, you want to directly save a Python object. This could be a dictionary, this could be a list, it could actually be an instance of a class like in this case here. Now it's very difficult to do that, and usually what you'll have to do is convert that Python object into something like JSON or into something like a list, some type that can easily be saved in a file. You'll have to save it there, and then later when you're loading it back in, you'll have to parse through that data and then convert it back into the Python object that you want. Now that is a bit of a pain, and fortunately Python has a solution for us, which is to use pickle. Pickle allows us to save any Python object in a file. So to illustrate that, I have this example where I've created an instance of this dog. Now this is a custom class that I've written myself, and what I want to do is save this dog instance. So what I'm going to do is open a new file here that has a pickle extension, so .pkl. I'm also going to open it in the write bytes mode because we're going to be saving this as bytes, not as text. What I can do to save this dog object here is I can simply dump it using pickle. So I can say pickle.dump. I take my data, which is my dog object, but it could be any Python type that I want, and then I save it to this file. Now later on, I can go ahead and open this file. We're just doing this for example purposes. So I can open data.pickle in the read bytes mode. That's what RB stands for. And then I can load in this object by doing pickle.load and then loading in the file. When I do this, it's going to give me the exact same dog instance that I had before, and I'll show you that by printing out the loaded data and then calling a method that's only available on the dog type. So let's run the code here, and you can see that we get our main dog object, and we get my name is Max, and I am a 10-year-old golden retriever. So that is how you can save any valid Python object using Pickle. It's very useful, especially when you don't want to be converting, say, a complex class into something like JSON before you save it. Now, before we get into these next functions, I do want to let you know that I do have an entire software development course where I partner with Course Careers and a few other instructors that are experts in their respective field. The way that this course works is you go through the software development fundamentals, which is taught by myself, and then you actually take a specialization course in front-end, back-end, or DevOps. All of this is included in the price. It's a really great value. We've already had a lot of success landing students' jobs. If you're interested in landing a job in 2024 and beyond, or you just want to level up your software development skills, definitely check it out. It is a ton of content, tons of practice, and we have entire sections dedicated to helping you fine-tune your resume, portfolio, and actually how you look for jobs and apply to them successfully. This is really the guidance that a lot of people need in order to break into the industry. And even if you're not interested in purchasing the course, we have an entire free introduction course. It's about an hour and a half long that you can access by clicking the link in the description. Anyways, with that said, let's get into our next function. Now moving on, the next function on my list is the any function. Now the any function simply tells you if any of the values in an iterable object result in true or equivalent to true. Now if we're looking at the numbers list right here, we have 0, 1, 2, 3, 4. 0 would be a falsy value. 1, 2, and 3 would all be equivalent to true if they were to be converted to a Boolean. So when I print any on numbers, it just looks at all of the numbers, and if even just one of the values inside of this iterable is true, then it returns true. So in this case, we would get true. Now, another way that we can use the any function is by actually having a comprehension inside of it. So what I'm doing here is I'm looping through all of the numbers in my next numbers list, and I'm checking if any of them are greater than 0. Now, this is going to give me an array inside of here that has true and false for all of the respective values that are inside of numbers, and then we're checking if any of those are true, well, then this whole thing would return true. In this case, none of them are, so we would get false. Next, we can do this with strings. Same thing, I can check if any of the strings are empty, and if they are, then we can return true. Notice that this is a much faster way to check for the presence of a value, and also allows you to write some more readable code because you can write expressions in one line, whereas normally to do this, to check if any of the values are true or equal to something, you need to write an entire for loop, go through, set a flag, see if something is true. Now another example usage here is something like checking for the existence of files. So what I'm doing here is looking if any of these files here exist inside of the current path. If they do, then I will return true, right? So another useful thing you may potentially want to do. Now this leads me really nicely into the next example, which is the all function. The all function works pretty much the exact same way as the any function, except it checks if all of the values are true. So if all of them are true, we get true. If even one of them is false, then we would get false. I'm not going to run this code. I think it's fairly straightforward, but any and all can be quite useful and can allow you to write some more readable code and to evaluate things in a single line rather than having to write out these more detailed for loop or while loop checks. Moving on to the next function, we have enumerate. Now enumerate is a simple function that allows you to iterate by both an index as well as a value when you're looking through any iterable object. Most commonly used for list, but really can be used for anything that's iterable. So a string, a tuple, some other type as well. Now what this will do is give you a tuple that contains the index first and then the value of whatever you're iterating over. So when we look at enumerate, we can pass to it any iterable object. In this case, I'm passing it a list. Now we can also optionally pass it a start value, but for now, let's look at it without that. What this is effectively going to do is generate an iterator that will return these values. So 0 Alice, 1 Bob, 2 Charlie, which means you can loop over it by doing for index name, and then the index will be equal to whatever the index is, and then the name will be equal to, well, whatever the value is. Now, optionally, you can pass a start value. So if I pass something like start equals 1, if this autocomplete will go away, what's going to happen now is rather than starting at an index of 0, you will start at an index of 1, which means now you would get actually kind of the true positions starting at 1 rather than starting at 0. So obviously you can see why this would be useful when you need both of those pieces of information. And in this case now, if I were to run my code, you can see that we get a nice list here where we have 1 Alice, 2 Bob, and then 3 Charlie. There's a lot of other use cases for enumerate, but typically used in the context of a for loop when you need to access the index as well as the value when you're iterating over something. Moving on, the next function that I have is counter, and this comes from the collections library, just like one of the previous ones that we looked at. Now, what counter allows us to do is create an object that counts all of the instances or frequencies of specific words, characters, objects, doesn't really matter what it is, inside of an iterable object. So in this case, I have a list of strings, and maybe I want to count the frequency of all of these strings, or how many times all of these fruits exist. Now, rather than doing that manually using a dictionary and using a for loop, I can simply invoke the counter from the collections module. So what I do is say count is equal to counter, and then I pass my iterable object. This does not need to be a list. And now when I print out the count, I'm going to have the frequency of all of these different objects. If I want to access the frequency of a single object, then I can use that with a key. So I can say count and then something like apple, and now we're going to get the value directly, which is 3. That's about it. There's a few other operations you can do with the counter, but this is useful when you very quickly want to get the frequency of all of the different objects that exist inside of an iterable object. The next function on my list is the timeit function. Now this comes from the timeit module, which is built into Python, and as it suggests, it allows us to time how long certain code takes to run. Now there's two ways that we can invoke the timeit function. We can pass a string to it, which is what we're doing right here with some code that we want to execute, or we can pass a function, which is the way that I'm doing it here. Now by default, the timeit function will run this code 1,000,000 times and then take the average on how long it takes to execute. However, as you can see here, I can specify the number of times that I'd like to run it myself. So in this case, 100,000 times if I want to speed up the operation. Now here, we're just going to compare using a list comprehension to generate squares compared to using the map function. And let's see which one actually runs faster. So when I execute this here, you can see that the list comprehension took 0.3 seconds and the map function took 0.4 seconds. So we'd want to use the list comprehension. If we clear that and decide to run it again, you can see in this case, actually it took less time. If we wanted to have a more consistent result, then we would just run this more times. And again, if we removed the number value here, by default, it will run it 1,000,000 times. This is a very fast way to time different implementations of code. So if you want to check for yourself what way you should do something, or you have some code that's maybe performance dependent, then definitely try using the timeit module. Moving on, we have the chain function, which comes from the itertools module. Now, itertools has a bunch of very useful functions, so I'd recommend that you check it out, but chain is one that you'll want to know about. Now, in order to understand the value of chain, I want to talk about what happens when we do something like a list concatenation. So if you want to combine two lists together in Python, there's a few different ways to do that, but a common approach is to simply add them together. When you do that, all the values from list 2 will be added to the end of list 1, but what this is going to do is immediately create a new list for you that has all of those different values. That means that all of those values are going to be stored in memory immediately, and you have them there even though you might not necessarily need them at the current point in time. Now, what the chain function will do is effectively the exact same thing as this list concatenation, but rather than creating a new object in memory and immediately storing all of these new values, it's going to create an iterator that will step over the values from, in this case, list 1 and list 2. Now, when we use an iterator, the values are not immediately available to us. What that means is that we're going to access them when we actually need them. Now, if you haven't looked at iterators before, I understand this can be a little bit confusing, but a lot of objects in Python, you'll notice you need to use this list function on. If you want to actually view what they are and print them out in the console, you first have to convert them to a list, so something like the map object or the filter object, or in this case, the chain object. And the reason for that is that they're not actually a list, or they're not a tuple. They don't have all of the values immediately available. Instead, they just return the values when they're needed. That means that you're not storing all of these values in memory at the time that you create this new object. You're simply making an object that allows you to access them when you need them. Let me show you what I mean by this. So when I run the code here, you can see that we get the same thing. However, if instead of converting this to a list, I just use the chain function here, you'll notice that when I print this, I get this itertools.chain object. That's telling me that this is actually an iterator, and it doesn't yet have all of the values. It's waiting until I actually need them. Now, in order to verify that for you, I'm going to use this function called next. Now, next will give you the next value from an iterable object. So I can say print, and then, sorry, this is going to be combined chain. And when I do this, it's going to give me the first value from the iterator. So you can see that we get that. We get 1, and then we get 1, 2, 3, and then we get the itertools object because I'm still printing this out. So let me stop printing that. Now I can use the next function as many times as I want, and I'll get the next value in that sequence. So I get 1, 2, and then eventually if I keep going, I would get A, B, C. So I'm not sure if you're understanding where I'm going here, but the point is that rather than giving us all of these at once and storing them in memory where we might not actually yet need them, it just gives it to us one at a time, which means as we're iterating over this with something like a for loop, we only actually need to have one new value in memory, the value that we're currently processing, not a combination of all of the different values. Now this isn't important in a small example, but if you can imagine that list 1 and list 2 had 1 million values each, if we concatenated them together, we'd immediately be storing 2 million values in memory. Rather than doing that and duplicating all of these values into a new list, we can use something like chain, where it sets up the iterator to loop through list 1 and list 2 without creating any new values. It simply gives us the value from list 1 or list 2, depending on where we are in the iteration, when we need it to process it. Now, obviously, if you convert this to a list, then you kind of void the point of using chain. I just did that so I can show you what it looks like when we print it out. Hopefully that makes a bit of sense. If you want more on iterators, I have a video here that I will leave on the screen. The next function that I have for you is the dataclass function. Now this is a new function, I believe in Python 3.11, but it might be in an earlier version, but to be safe, let's say 3.11. And this acts as a decorator to decorate a class. Now what the dataclass decorator will do is automatically implement some methods for you that are common when you're writing a data class. A data class is a class that typically doesn't have a ton of different operations, but instead is used to organize or store specific data. In this case, we might have a person class where we want to store a name, age, and job. Now we could have some functionality on this class as well, but typically what we're going to need for this class is something like an initialization, we're going to need a representation, we're going to need maybe a way to check for equivalence between these two objects. Now the data class decorator pretty much does all of that for us. It actually implements all of those methods based on the different attributes that we define with their respective types. So all I do is say that I want a name that's a string, an age that's an int, and a job that's a string. And when we have this data class decorator on top, it automatically implements the initialization, so underscore underscore init underscore underscore, the repr, so underscore underscore repr, underscore underscore, and the equal method. This allows us to utilize this object very quickly without having to define all of those ourselves. Now, just to show that to you, if I run the code here, you can see that when we print out the person, we get a nice representation of that. We also could check for equivalence between two people. So if we make a new person here, we can say person 2 like that, and then we can say person is equal to person 2, and in this case they should be the same. In this case they are, because they have all the same values. But if I change one of the names to, for example, something like John, when we run this now, we get false. Now, just to show you exactly what this actually does, I have an expanded version of this example. So if we look at this here, this is the equivalent code to what you saw right here. Okay, so it's the exact same what we're looking at. This is the implementation of the initialization. This is the implementation of the repr. So we need to kind of write all of this out and do the nice formatting of printing out these values. And this is the implementation of the equal, checking is this the same instance? Do these have the same values, etc. So this just saves us a lot of time and kind of gives us that boilerplate code. There's a few options that you can pass to data class, but I'm not going to get into that here. If you want more information on the data class decorator, I will leave a video on the screen that you can check out. So that covers the 10 Python functions that will make your life easier. Let me know in the comments down below which one was your favorite, or if I missed any that you think are useful. With that said, I will see you in the next video.